This conference will now be recorded.
Good afternoon to all. So, as part of our Swachhata Pakvada, we are having the series of talks by various scientists and people. So, as part of the program, today we have Dr. Vijaya Ravichandran, and later we are going to have talk from Mishra sir from NCCR. So the first talk will be on Swachh coastal waters, technologies for sustainability. And the next talk by Parvakar Mishra sir will be on monitoring coastal waters, lessons learned. So first talk, madam, you can start, ma'am.
Thank you, Satya. Good afternoon to all. Am I audible?
Yes, ma'am.
Yeah. Okay. So Swachhata, in the sense for NIOT, is not about just cleaning, brooming, removing stuff from campus, and teaching people how to remain clean. But we all have gone one step ahead and been using the technologies for uh, cleansing of several of our processes. Like last week we saw that we saw how clean technologies were employed for the vessel management, and how environmental impacts were being assessed for a sustainable mining program. So this coastal group, as part of coastal group, we have forever being we have forever been monitoring, observing the coastal waters for their the various pollutants that enter there, and how technologies can be employed in keeping them clean. So this presentation shall include a brief on coastal discharges that happen and pollution issues associated with marine infrastructure development, and impacts on marine water quality. These are not possible impacts, these are impacts that have already been assessed on the marine water quality, ecology and environment, and how we use technologies for assessment of the pollution issues, and what are the controls that we can apply at the source, or for managing the fate and transport of these pollutions through modeling, and what are the engineering designs that can be adopted in the process or the project design to ensure a clean marine environment. So the base bottom line is that coastal infrastructure has to be there, development has to be there. So we have the ports, harbors, shipping, mining, oil exploration, dredging for navigational channels that form major of the marine infrastructure. Coastal tourism also is a major infrastructure and also a threat to the environment and the coastal waters. Then there are marine outfalls. Of late, there are several industries that discharge their treated or untreated waters into the marine environment. So the environmental concern depends on the site-specific habitats that are there. It could affect the mangrove, seagrass, corals, which we have seen in several parts of Gujarat where there are corals and mangroves. Then whenever there is a dredging or mining issue, we have sediment resuspension, and whatever heavy metals are there inside the sediments, they get released into the water column and thereby contaminate, and it can lead to fish kills. Then there are ballast waters and anti-fouling paints, which also are found to, we have ourselves mapped that non-indigenous species are introduced into the environment, and these are a real threat. It's like a threat of KFC to the local Italy shop, to mean it very crudely. So the non-indigenous species survive really well in our coastal waters, and they almost remove all the indigenous species. Then there are risks associated with cargo handling, like uh, crude oil, and we know about the recent oil spill and the issue that it had on the coastal waters. Then we have chemicals that are being handled, fuel products, petrochemical products, benzene, uh, of which NIOT has carried out several risk assessment studies. Then, of course, because of the infrastructure, we have seen that there are erosion, accretion issues to the coast, which also result in coastal water quality issues, which I will explain in my slides. Then there are discharges, the sewage. The major polluter is a municipality which discharges sewage into the atmosphere, into the coastal waters. Then we have other releases like chemical, thermal. Thermal is a major impact now, and then brine from desalination plants. Then fishing industry is itself a big threat to the coastal environment, because they do tend to have the small net sizes, and they have overfishing. They catch hold of juveniles in that small net sizes, and which is lost. It's thrown back into the waters, and overfishing itself is a big threat. Then, because of coastal tourism, there can be pressure on coastal infrastructure. It can be withdrawal of groundwater, pollution of the near shore waters, and excess of transport, oil spills, and all that. So, unless we understand the background, it will be difficult to appreciate the what leads to the uncleanness of the coastal waters. So there are regulatory mechanisms in the country. There are the Marpol Convention, which handles the largely to shipping. Then we have the MOEF, EIA, and CRZ notification. And then we have CPCB water quality standards, which define the uses of coastal waters. It as SW1, 2, 3. They define the levels of BOD, DO, and petrocarbons and all that in the waters. Largely to which we have to adhere. Whoever discharges into the water has to adhere to this, one of the coastal water quality standards defined by CPCB. Then, of course, there are voluntary mechanisms like ISO 14,000, ISO 18,000, which is about safety. So these are some of the regulatory mechanisms that exist for controls. So these are the coastal waters are a source. They are source of food, water for processes, because large water withdrawals happen for desalination, for cooling water, and other industries. Then they are ecological resources. They have the seagrass, they have the mangroves, the habitats, and they are the source of minerals, health, the sea, drugs from the sea. Then we have the fossil fuels and energy, and they are climate stabilizers also. So they are a sink for cooling waters, processed waters, effluents, and carbon. So why are the waters discharged into the coastal waters? Why are the processed waters discharged? It is because there are large water depths, and it has quite a high dilution capacity, and the wave action mixes it, it dilutes it, and the currents transport it. So the fate and transport happens there. It happens in dilution and dispersion. So what are all discharged? So we have heated water from power plants, then municipal outfalls, which discharge the sewage, treated, untreated, anything, name it. Then we have the processed waters from refineries and chemical industries. So these are all the industries, so which discharge into the coastal waters. So these are some of the outfalls that we've taken pictures where mainly they have an outfall for meeting the statutory requirement, but they are never maintained. You see, this was a long back photo. Now it has been repaired, but to have an idea, this is a Royapuram, north of the Royapuram fishing harbour. This is a marine outfall for sewage. You see, this is a raw sewage from Chennai being discharged into the near shore waters. And this is a Ashok Leyland pipeline, which is supposedly should go up to 5-meter water depths. You can see that it is fractured and it can discharge anywhere, but on paper they have a marine outfall. And this used to be the fly ash disposal long back. This is quite long back, and this is some of the discharges that happen into the Buckingham Canal. This is the Amula Oil Canal in the Ennur Creek, where there is discharge is received from the chemical industries. So these are the some of the water quality issues in the North Chennai coast. See, this is the Ennur Creek. And you have so many connections to the Ennur Creek. This is the Kosastale River, which comes all the way from the north. Then you have the Buckingham Canal, north, and then you have this Amula Oil. There is a Amula Oil Canal, the Kotalia River. See, all this is important because many of them carry unclean or untreated waters from the North Chennai industry. There are several industries in North Chennai Manali belt, and previously there were there was no such control, but right now it is presumed to have controls. It is presumed that treated waters are discharged, but it has largely impacted the Ennur Creek. And here, since the mouth, you see the mouth of the Ennur Creek, it largely remains closed. So it is all the sewage remains inside. All the not only sewage, it's the all effluents largely remain inside, and it has severely impacted the fishing ground inside the Ennur Creek. If it is open, it will also connect to the open sea, and it will because it cannot flow northward because of the Ennur port, and because southerly drift is not very prevalent in this area, only it occurs only for 4 months, it will remain here. So it will largely impact the near shore areas, because the near shore areas are breeding grounds for and nursing grounds for fisheries, and that is why it is essential that we keep these waters clean. So these are all the, like, it is a pollution load of the various industries. We have listed all the industries from ETPS, NCTPS to MPL, IMRL, all these industries. This is the BOD, all the loads. Just see how much load is coming from the industry and it is getting discharged. So we have done synoptic measurements where the load in the industry is measured, and at the same time it is measured in the outlets as well as the receiving waters, to see how well it gets diluted. So this is all the, so as we have been largely hearing, before treatment testing is very essential. So now we have carried lot of water quality and sediment quality analysis all along the North Chennai coastal waters and inside the creek at various confluences, and current meters are also installed to measure the current directions, speeds, to see the dilution capacity, and it is measured during both low tide and high tide. For the creek, it is called ebbing and flooding. So when there is a flood tide also, the fresh water comes in, and when there is ebbing, the fresh water flows, the waters from the creek goes out. So that how much dilution happens during such a mixing is also being measured. So this is a thermal measurements from the NCTPS. So NCTPS was discharging 27 cumex of heated water at 36 degrees. It's about 5 degrees above ambient, and the velocities was this. See, this is during ebb. You see the waters The measurement, it is keep the heated water keeps moving outside, and during the flood it keeps moving inside. And the main thing about Ennur Creek is that the mouth is almost closed, and some dredging happens to get by the ETPS and NCTPS to get water inside the creek. Otherwise, the mouth is always closed. It's a very small opening. So you can see the plume, it just moves back and forth inside the Ennur Creek. So this is the highest temperature where it is discharged from NCTPS, and it keeps moving back and forth. I'll show you in the other slides. So this is the measurements that we took in May when the discharge was happening. It hardly dissipates because there is no mixing, and actually it is this white. I don't know whether you can see them in your system. This is the white patch that shows the vapor. It's the vapor. This is the vapor that is visible from the plume. So we had to go inside, and these are the vapors that we have caught. And it actually moves within the creek. It doesn't dissipate at all, and it never comes less than 3 degrees above ambient. So you can imagine the fate of the fish or benthic population there, and also the synergistic effects that it can have on the chemicals that are being discharged inside the creek. Then Puam. I can imagine all of you holding your nose. It's a open sewer for almost it runs almost throughout the city. This we had recently carried out water quality analysis. Our intention was to keep the mouth open. The first condition that we told government of Tamil Nadu was that unless you treat the waters, sewage that is discharged into the plume, or unless you remove all the sewage collected and discharge it out offshore through a deep water outfall, please don't think of opening the mouth. And you can imagine what will happen if it opens and all this sewage gets into the open coastal waters. You can imagine what will happen to Marina. I'm sure Dr. Mishra will present it in his next presentation. So it is we have measured water quality inside it. It's raw sewage. It's an open drain, and it is better if it is closed, if the mouth of the plume is closed, because it will get treated within here, open treatment, and it will be better off than mixing with the coastal waters. But then Tamil Nadu government has plans to have 6 treatment plants along the plume. They are taking the water, they're treating it and letting back. These are all their plans. They're letting it back into the plume, and they propose to do boating. That is why they want the mouth to be open, and so that fresh water comes into the mouth, and then it kind of disinfects or cleanses, keeps it clean. So these are this point is the Cherpet Bridge. So it goes. It's a real river. So it has. You can see the meandering of the river, and you can see the island. It's too small to be visible here. You can see the Chepak Island. See, this is the Chepak Island, and then it has 2 arms. It goes like this, and it traverses like this, and you can see this is the Cherpet Bridge. And then we have collected samples inside also. We have collected raw sewage from inside and also the coastal water quality. Inside, the depths are so poor, we had to have separate designs to have the boat. We had to pull the boat from one side to the other with people measuring it. We had to make some changes to our measurement pattern. So the main thing about plume is that you should understand the mouth dynamics before flushing the plume. Getting into flushing the plume, we have to understand the mouth dynamics because it remains closed for most part of the year. The main reason being the Chennai port, which has led to accretion on the southern side, and largely almost in NIOT everybody will be familiar that the sediment transport is from the south to the north for most part of the year. from almost November to April to November, and then it is towards south in the rest of the year. So 4 months in the year. So this is the mouth. April it is open. You can see it's kind of open. Then from north to south, it starts accreting, and then you can see the whole tongue formation, and then in September it starts reversing. This tongue is slowly getting away, and it starts from the south. So then November, when there are flood waters, they are opened by the PWD, and the flood waters are flushed out, and that is when we get the highest water quality issues. And again in February it starts forming from the north. And this sediments are basically that move between the Chennai port and the Marina beach. They move between Buoy and the Marina beach, and you can see that already they had some groins, and there is a accretion to the north, and there is some soil sand there, and to the south also. So before we try to flush this open, we need to understand the mouth dynamics, which we have studied through satellite imageries, and then we have come up with several alternatives about how to keep it open. So you can see I will discuss some of the water quality issues. See, this is the dissolved oxygen. The river stretches, you can see it is almost zero. That is more near the mouth. This is, see, there is no life in the waters. And similarly, you can see the high amount of ammoniacal nitrogen, which shows that it is raw sewage. And you can see the comparison of coastal stretches where the dissolved oxygen is quite high. So what happens if these waters come here? They might dilute, but it will the pollution signal can be caught even up to about a few kilometers south. They have so much fecal coliforms in them, so they don't suit the water quality standard, designated water quality standards of the CPCB for beach users. Then coastal waters off Chennai. There are several outfalls of Chennai, north of Rayapuram harbor, up to Ennur. So there are combined water outfalls from MFL, MPL, Tamil Nadu Petro Products, Madras Fertilizers, and all these. And there are singular outfalls, and there are treated waters. These treated waters are generally carried out. Off late, they have been shifting it to 8-meter water depths into the coastal waters. So these are some of the technological interventions. First one is about keeping the Ennur mouth open to enable flushing. So this is the dredging that we propose inside the Ennur Creek, and remove all the contaminated sediments right now, and then keeping the mouth constantly open, and plugging of all the discharges inside. And this is the curved training wall. Actually, it has to be also it is very important that the maintenance is kept as low as possible, so that later it doesn't fail because of maintenance issues. So we have done several options, just the deepening. There are straight training walls, there are curved training walls, all that, and we have seen which is the best, which gave the best solution. And this one gives the best solution because it doesn't sit so fast, and inside also the deposition is quite it's just comparable. You see, it is 48,000 and odd, and the dredging is minimum inside, so that will at least enable them to maintain it for a longer time. And this is the Buoy mouth. So what we have suggested is that dredging up to this island, and then maintaining of a constant depth inside the river, and all the encroachments to be removed all along the Buoy, and all that is a social issue. They have removed all the encroachments because unregulated sewage doesn't get into Buoy. And then we have studied several options for keeping the mouth open. And as you know, this is more critical because of the Marina beach formation and the North Chennai, the Chennai harbor. So this is again we have seen which is the least, because their investment has to be low, the maintenance also should be low. So we have tried various options through a numerical model, for which of course we have done bathymetry on the outer side, bathymetry inside, and done this, set up the model, calibrated it, and then we have ensured that it keeps flushing, of course with the condition that they let only treated waters into the pool. Then this is the NCTPS. See, with the existing capacity of NCTPS, the modeling has been done, and this is for the creek during flood tide, mouth closed, because the mouth closed condition, you can see that the plume keeps traveling inside only, and even during flood it has to go out. Sorry, it has to come in. It just comes in, and hardly any water comes from outside to flood it inside. During ebb, just see how much it doesn't go beyond out. This heated water remains here only. It is not going out. Similarly, during mouth open, at least some water comes in. If you dredge the mouth, we have assumed that the mouth is dredged, and you can see that the plume moves more inside, but still the heated water is here. It doesn't dissipate. And here during ebb also, it doesn't dissipate beyond this point, and this keeps remaining here. Now they wanted to increase the capacity of NCTPS, and we have modeled that condition also, and then it is still worse. It still doesn't dissipate. It moves within the creek only for all the conditions. So what is the solution for this? We have told them that they should have marine outfalls to have enough dispersion, and designing of the marine outfall, it is a subsea bed pipeline that goes into the offshore area. Depending on the dilution capacity and the currents, several modeling scenarios are done to see which is the optimum depth for discharging the water. There are also diffusers are designed so that the mixing happens very quickly, and the water is dissipated, the temperature is dissipated very quickly within about 500 meters, and then it flows along the using the currents. So the currents take them away. So this is very essential to design, and all the problems of head losses, everything. We have done the detail engineering for this. This is for a 4,000 megawatt power plant at Chennai, which we designed, and we have done this all detailed engineering studies for the diffuser and the outfall location. We have also done Mike 21 analysis for the outfall and seen how the plume, the temperature plume behaves during monsoon, and because the circulation patterns are different during monsoon and non-monsoon. This is monsoon, and see, you can see that the dissipation happens, and beyond this you cannot see the plume. It was only within 500 meters you can see this plume, and then it dissipates. Then it still, this southern, when it moves to the south, it is essential to check how far it goes, because the intake has to be placed beyond the this region, so that you get cool waters for the intake. So this is for the monsoon, and this is for the non-monsoon. See, it doesn't come to the south at all. I'm sorry about the slide. This is during non-monsoon, and it keeps going north, and the dissipation occurs. You can see the plume beyond this. It has dissipated completely. The green has gone, and it becomes one of the ambient. So this is one of the process designs that we can use even for NCTPS when we want to discharge it outside. Then we have for the North Chennai outfall, you can see these are the groins. These are the groins along the North Chennai beyond Rayapuram Harbour. This is the outfall. This is the Manali outfall. We have done some measurements. We have placed tide gauges, current meters here, and we have taken the benthic and water quality samples. And you can see the impact on the benthos. Here you see this is a 2000. The blue, dark blue is an NIOT study, and you can see there is a drastic fall in the benthic values in that area, because they don't change their location. They remain there forever. And so this has a, of course, we cannot attribute it to MPL alone, because that's also dicey not to get into such blaming, because the entire belt between Raipuram and Ennur Creek is polluted with all these discharges from several of these industries as well as from municipal waste. So this was the report given to them. And then now, uh, uh, as part of NGT, it went to NGT, the National Green Tribunal, because based on our report, the fishing community has gone to Green Tribunal, and NIOT is on the Green Tribunal now. So now again measurements were carried. We can see that there is a slight improvement. There is a fall. So we should, it requires, really requires long term studies to see what is the reason for this up and down. And it cannot, we cannot jump to conclusions immediately, but these studies are very important for us to know that such problems exist. So we have been studying the North Chennai coastal water since 1999. So we have vast data. We have studied inside the Ennur Creek and all along the coast. And we have mapped the physico-chemical parameters, biological characteristics. Toxicity is a big issue here. Sediments are toxic because of the heavy metals. And then, being a member of NGT, we have we have been part of the team to carry out the analysis and suggest to the industries ways of ensuring clean coastal waters, discharging coastal waters of North Chennai. So to conclude, coastal infrastructure is required for development, and it has embedded pollution issues embedded into it that we need to accept. But solutions are there to ensure clean waters. Uh, like we can and sustainability, for sustainable approach, we need to have a scientific way of measurement. Even the planning of measurement needs to have a scientific effort approach, because we need to take into effect the current directions, the tidal variations, the wave, because if you measure on a very high wave day, or when there are huge currents, there is no use, because it would have all dissipated. It will not represent the status quo of the area. So the approach is very essential for measurements and for solutions. Then no, the long-term studies are very essential, because the manifestation of this impacts in biology takes a long time. And no knee-jerk reaction helps, like just go put something there, change some process, doesn't help. So it has to be accompanied by long-term studies as well as measurements, mapping, and all that. And we need to learn from our mistakes, because for example, the shoreline management itself, over the years we have improved, and what was correct at 20 years back may not be correct in the long term. So we need to audit the existing solutions, existing procedures, and then learn and change the approach. And of course, technology provides an alternative. It can have an alternative process. It can have engineering designs for source reduction. Like NCTPS, we had the NIOT study for NIOT plant for using the waste to heat conversion. So that's very, that kind of it will enable use of the heated water for better a sustainable use. And you need not, because marine outfalls are expensive, they have huge maintenance, and they have their own, of course they have their own issues with them. But these processes can enable better solutions. And also cogeneration, like having a desalination plant as well, combined with the thermal power plant, helps, because the water, when the discharge waters can be mixed together, and dilution can help, as well as the water temperatures can be brought down. And of course, everything has to be a site specific solution, because no site is same. We have seen in our own experience, we have worked in several sites, and each site has a unique issue with respect to the orientation, with respect to the oceanographic parameters, as well as discharges. So it has to be site specific. And then long-term mitigation plans have to be developed, management options have to be there. But we see that it often fails because there is no ownership of the coastal areas, and fund allocated for monitoring and mid-project changes are not really utilized. And then as a whole, we see that lack of ownership, like anybody can go, there are several stakeholders, but anybody can go and give a back of envelope solution for the problem, and it is implemented without knowing its effects, and then people suffer in the long term. So like immediately go and put some groins, putting some outfalls, like that also prevails, because anybody who terms themselves as a coastal engineer, they just do immediately without many of these measurements, because measurements are very expensive, they have to be very comprehensive, and they need a lot of effort and planning. So nobody has the resources, they just go and give some solution, and because of immediate solution, because the impacts will be borne by others. So I think this has to be addressed at the policy level. This is out of our experience of handling all these projects. Thank you.
Thanks very much, ma'am.
Satya, you can allow 1 or 2 questions, I think.
Yes, ma'am. So thank you very much, ma'am, for very informative talk. If anyone have any questions, we can take. We can take 1 or 2 questions.
Can I ask a question?
Yeah.
No, Vijay, your first slide itself said why, the why had the dispersion is like it happens easily or something. But obviously the truth is not that, right? I mean, were it
Yeah,
to have,
it is a presumption.
Correct. So how good are my next means related thing is, how good are these dispersion studies really? I mean, in your experience with the practical thing, the studies that you have been carrying out, have you done post monitoring or something like that to match and whether it really worked?
Yeah, we are doing, we have done for, not for thermal, but we have done for outfalls, and the deeper depths are better off, and the impact is not more on the water quality. Of course, there is an impact in biology. You saw that the the benthos were numbers were low, so there is a issue with that dispersion also. It really is not dispersing at that site. So it has to be source controlled. It has to be treated and then only dispersed. Actually, it is a presumption that it will disperse due to high dilution capacity.
Thank you.
Yeah. So any other questions? If anyone wants to ask one more question, they can ask. Okay, if there are no other questions, thank you very much, ma'am, for your informative talk. And before going into our next talk, I request all the members who are participating to switch on their cameras so that we can take a snapshot.
And I thank you all very much, the organizers, to have given this opportunity for discussing this North Chennai problem, because we've been working on this.
Can everybody turn the cameras on, please, just for a second? And Sajiv and Trishanu?
Yeah, for a second, please switch on your cameras. You'll take a snapshot.
It has gone black. It's gone off for me.
Trishanu, are you there? Sajiv?
Yes, sir.
Yeah, okay. You are ready now?
Hello, can everyone turn the cameras on, please? Just for 1 second.
Maybe everybody may not be having camera. That's
Yeah,
the
those who don't have, it's okay, but those who have,
Mm.
just a second.
Yeah, ma'am. Actually, most of them are attending from their desktop. So most of the desktops are not having cameras.
Yeah, okay. Fine, then you take this shot itself, the number of people is showing.
Yeah, we can proceed, ma'am.
Yeah, you can. Yeah, okay. Thank you, Trishna. So now we will continue to our next webinar by Dr. Mishra from NCCR. It is on monitoring our coastal water lessons learned. Sir, you can start.
Can I get the sharing link? Hello?
No, you are already sharing your screen, sir. So just click on the PPT. Then you'll be able to show it.
Sir. It's okay?
Yes.
Hello? Yeah.
We are able to see your screen, sir.
Oh, I can.
Yeah, go to yes, sir. Okay.
Yes.
Yes, sir. It is visible now.
Okay, thank you. Yeah. Yeah, well, good day to all of you. This is I think thanks to Dr. Vijaya because she made my job easy. And regarding this topic, monitoring our coastal waters, the lessons we learned, actually the background note has been already given by Dr. Vijaya. So I'll go a little faster with my slides. So being a research center, coastal research center, we are sitting along this coast. So we are continuously monitoring. We have the different agendas like shoreline management plans, coastal hazard studies, coastal pollution. But this coast we are monitoring for the last, I can say for the 2 decades. And so this, why the question is why we should be worried about our coast, because as it is we all know that this is the sustainable use of the coastal waters and resources is linked to the benefit of our economy, our health, as well as our cultural values and traditional livelihoods. So but as in the last speaker told, has already described that we are highly affected because of heavily used, close to the sources of pollution, shallow water bodies, poor circulation, and this trend are expected to increase. Well, we as a research center sitting here, we are monitoring the coast and the entire Indian coast for the last more than 2 decades, more than 3 decades, and we are having continuous data at different places. And these are you can see these are the parameters we are monitoring, and we have a seasonal sampling strategy. And what these data for the last so many years we have collected, that says that all over along the entire Indian coast, things are becoming slowly bad. That means the water quality parameters, if you put it in the water quality index, taking all the parameters like oxygen saturation, BOD, the nutrients and the fecal coliforms, and you make it a index value, you can find that the entire water quality along the Indian coast is slowly deteriorating. Having said that, we have a vision that to start something like how to maintain our beach, how to maintain our coastal ecosystems, and also if you look at the developed countries, they classify their coast and their beaches, and based on that is the blue flag beaches. You must have heard of this thing. So that on certain parameters, they qualify the beaches to whether that should be allowable for taking baths, for recreation, and that can be certified as a blue flag beach. And that was our motto. And how whether we can able to demarcate our beaches, our coastline, whether we have some of the beaches which are very clean, pristine beaches. And we have started thinking that, keeping this as background, we started Swachh Seva, where we took almost all the problems into account, and we, as a pilot project, we started monitoring the Chennai coast. And because we are sitting here, and we are monitoring since 2013 on a regular, seasonal, monthly basis, not a monthly basis. And we have a number of events we have recorded, which I thought that this is the right place to give a presentation on this. And besides that, we have also some sort of to develop a criteria for the seawater quality criteria for different heavy metals for different environment. That is like a lagoonal environment or estuarine environment. And as we have experiment, our experiment site is Ennore. And after 20, you can see, ultimately we found some values for different metals, but these numbers which has been notified, which is notified in the Gazette, but this is a simple number, looks like a simple number, but it is our 20 years effort. So if people knows Dr. Mohan, his entire service period was dedicated. I can say that he made the effort to get these values, and now it has been published by the Gazette notification. So these values are very important. And the very important point, what we are seeing, that already Dr. Veja indicated that water quality standards for different uses criteria has been made, but these are all some 40 years back. These standards have been made, and they had now. Suppose let us take Chennai coastal water. Chennai coastal water can be used for many purposes. Let us say this, maybe we are using, there is a harbor, there is a navigation, there is bathing, there is also other economical activities, fishing. So now this thought needs to be relooked, and also we have to find out whether within the last 40 years, because the water quality has been changed so much, so what should be the value, that should be the criteria value for the different classification of these waters. So this is another important point which should be looked into. So what are the sources that make our coastal waters polluted? As already discussed, that there are wastewater treatment plants, untreated sewage, partially treated or whatever it may be, and there are non-point sources, that is like agricultural runoff that brings a lot of pesticides, fertilizers, and oil, grease from toxic chemicals from government runoff, and coliformia bacteria and river runoff. And if you look at the pollutants on the lower left panel, I have given a figure in which you can see that almost sewage is the highest contributor, 30% of the pollutants entering from the ocean. So sewage is the main culprit. Having said that, even the anthropogenic chemicals, that is 80% of all marine pollutions, are coming from the land-based activities. Keeping all this all this information in the background, the important point here is we are not the sewage what we are generating, less than 50%, less than almost 60% to 70% we are not treating. We do not have the treatment capability. Only 30% we are treating. So that is the main culprit in all our coastal water pollution. And once you look at this at any point, once the sewage enters to the environment, So automatically this from the clean zone, the system changes to the decomposition zone, then to a septic zone, then there is a slow recovery. And this happens within 5 to 10 kilometers within the coast. Means from the coast within the 5 to 10 kilometers you'll find, and slowly it makes it goes for the dilution, and automatically again the clean zone retreats. So this area, this our coastal area, is highly being a highly dynamic zone, and being underwent a lot of this detrimental effects. So this has always, there is a decay, or there is a oxygen demand in these coastal waters. So similarly, the nutrients that comes from the different, as I told of the agriculture runoff at sewage, they bring a lot of nutrients, and sewage also bring a lot of nutrients. And as we know, these nutrients, they give, they trigger the algal blooms in the coastal waters. Some pathogens, these are coming from different type of bacteria, that is for the sewage, livestock, open defecation, all these that contribute to the pathogens, and they indirectly or directly affect the people, those who go for recreation. Unknowingly they get the different types of disease, and there are different swimming related illness. But right now, as under the COVID pandemic, this is an imminent challenge. What I saw from while I was going through the literature, I found that IIT Gandhinagar, they have reported that the presence of the CoV2 virus in sewage, and which is they have highlighted that the need to introduce surveillance of wastewater right now, and monitoring for the spread of COVID and identification of potential hotspots is an immediate challenge for the country, coastal water. So we are going to the beach, we are not knowing. As you know, the sewage are being dumped in the Coombe River, and that can bring, that can also be contaminated with different types of virus in during this pandemic, and that can be coming to the Marina, and that can affect anybody who is entering to the water. And okay, there was an oil spill 3 years back, and that was the oil spill due to a tanker. This is a real picture near our groin field, and the right hand panel I'm showing. So this oil spill is another big problem for the coastal water. And thermal water discharge, same, the cooling for them they use, and they also already Dr. Vijay has explained about this. And the recent problem is that the plastic, and it has been the studies show that this in the form of microplastics is has already has increased to such an extent that by 2050 the total weight of microplastics or plastics in the ocean will be more than the total weight of the fish. That is the prediction. So these are the usual events, I can say, in along our coast, along the Chennai coast. So these are all due to the whatever the causes I described or I told, that is the reason. You can see sometimes people enter, there are some foams occur along the Marina beach, and that is reported in the newspapers, and people they are not aware of, they enter to the water. And similarly, there was some discoloration of coastal water. So then you can see there are debris, a lot of debris after the flood, 2015 flood. This is an example. So entire Marina was flooded with debris. So there is a mass fish kill occurs along the Coombe, as well as the Adyar river mouth, and recently it has occurred in the Puducherry also. And so to keeping this background at NCCR, we are regularly monitoring from Chennai, from Ennur to Puducherry. And we are using the ship, available ship, and as well as with the trawlers, and we have some sample protocols, so following protocols. So this is a picture which I hope you all will appreciate, and this is a usual phenomenon along the coast. So what we observe, that high PO4 and NH4 from Coombe and Adyar river, they are the foam is produced when the organic matter decomposes, and the organic matter in surface water comes mostly from the decomposing of algae and sewage and other organic discharges. So this is a regular interval, it is occurring for the last 5 to 6 years, what we have observed during our observation period. So At the same time, sometimes if you go to the regularly, if you have visited the Marina or Elliot or Tiruvallur beach, so you can find that suddenly there is a discoloration of the water. So there is people that they are not aware of what is this discoloration of water, and this is a some sort of blooming happens of the particular species of phytoplankton, and which is sometimes these blooms are also toxic. So though there is a harmful algal lurk in the waters of coastal water, but you can see at the same time a boy is taking a bath, but he or sees the people who are entering, they are not aware of the what is this, and they think that okay, it is something like a foam like thing, and it is more, you know, forthy, and it is more enjoyable. So this is also another important point which we have to keep in mind. At the same time, there was a mass fish kill and this has occurred along the coast at a regular interval, and we have seen we have measured that sediment enriched the comb mouth reef, the comb sediment, the Marina sediment, the Adyar sediment, all are enriched with cadmium and lead. And in another publication, they have seen that the chromium in the water is also high. So these are some of the factors which lead to the sudden spike of fish kill and sudden mass fish kill. The Marina waters are a concoction of bacteria, and the lower panel I am showing the pre-flood and flood and post-flood situation in the 2015. You can see because before the pre-flood, at least the water was choked, and with the flood season, the entire the Kuam and Adyar river, they flush out the entire bacteria, and for a period of time, for a few days, it was a clean moment, and again the same situation retreated and revived, and it became again highly bad. So these are all what is happening along this coast. And a few days back, that is in just a year back, 19th August 2019, suddenly there was a sparking, people observed a lot of sparkling along the breaker stone, and there was a hue and cry, there was a lot of report in the media, and this sparkling started with Panayar Kupam and moved towards Sakarai, then to Tiruvallur to northward, and ultimately dissipated. And this is nothing but a blooming of a Noctiluca scintilliens bloom, which is also we found when we investigated, we found that high nitrate after immediate high rainfall of during that phase of time, and there is a high nitrate availability that triggered the bloom. Similarly, there was a oil spill for which we made a detailed study for almost for a year. So with the different time lag, we took a lot of information, we collected the data, and we made also some models. And what we found that Ennore coast had 4 months after oil spill. That means till 4 months, the oil, the signature of the oils remained in the coast. And but though we are lucky to say that means there was no significant changes in phyto and zooplankton abundance, and also there is not much fish mortality, but there is a decline in the sales because there was a notion that maybe fish is contaminated, though there was good catch. So that shows that even that has at that point of time affected the fishermen as well as a lot of economic consideration. So, and we also try to look the data, and you can see the patches how the oil moved from the accident zone and how the oil has moved, and on the background you can see, and this no major changes was observed beyond 8 kilometers from the coast. So it went along the coast, and ultimately it got dissipated. So these are events are quite repetitive. That what we are learning is that what is the result is that this is quite repetitive, and these are occurring at different times. And this is but what for the last 5 years what we are monitoring, but how we are going to bring it to a normalcy or to a better condition, that is the questions. And similarly, we have also established some of the monitoring real-time monitoring station for Chennai coast. We have already deployed a buoy system, and we are trying to model the water quality model, develop a model, and we are also in the public. We have developed an app where we are disseminating this information. But whether these beaches are good or not, or the objective of the program is to identify the beaches, the clean beaches, and this is how you can this particular water quality buoy has been installed, and you can have a look. You can see that I've given a website address in the red. It has been shown in the reading, so you can see you can go and see the data online. Every 20 minutes you will get a data. So, but this data ultimately we are going to use for our prediction, developing a prediction system, and all these informations we have summarized, we are publishing, and we are making aware to the system, we are making aware to the government, and it is all in the system. But what to do, where we have to, how to attain to bring back to our coastal ecosystem, that is required to think. And added to that, there is another problem is the plastic. So this is a paper published by Jambeck in Science 2015. Sea has given an estimate that nearly 8 million metric tons of plastic waste goes into the ocean. As I told, there will be more fish, there will be more plastic than fish. And at that point of time, we are also we have initiated a research program on marine litter and microplastics, looking the basic point to find out from the source to sink, and the assessment of marine litter in MPs in the water sediment, because there is no available of data. So this is one attempt we are making. And we in the last year during coastal kill campaign we made, and we also did some 34 beaches, and along entire country, 26 coordinators, and they use almost 7,000 volunteers, and we collected 35 tons of plastics. And ultimately you can see what we got. The inference is that tourism and recreation is a major source. General waste and fishing were equally dominant at some of the beaches. So this marine litter, this is I am just giving an example that how the marine litter is coming to the coast. So we have done a hydrodynamic model, and we saw that whatever that is in Kuam, that comes to the beach. So we are also making some microplastic survey along the east coast, and so this is for the sediment, for the water, for commercial fishes. We have made a lot of, and we found a lot of polystyrene and polyethylene fragments. And so the lessons what we have learned, the coastal water quality degradation is basically a human created problem, as already cited by my previous lecture by Dr. Vijaya, that related to all our activities on the land affecting a negative impact on the coastal biota. And also you can add whatever the coastal economy, even coastal people and whatever. This can be solved only through proper timely human interventions. So having said that, we have a lot of legislation, as we know, but the crux of the problem, the point is strict compliance and enforcement. And these rules needs to be upgraded also with time, site specific, with local, with time. So these are some of the points that we should remember, that so the solution, we can find out there are a number of solutions, and already has been suggested also. It has been by any coastal zone management researcher, that immediate for this particular condition. And this is not the case of only Chennai. I can take an example of also, like the same condition is also in all the metro cities. They can take for Kochi, you can take the same example for Kadlur beach, Kadlur coast. You can take the same example for the Mumbai coast, for the Kolkata coast. So the situation is same. So management of sewers and affluents, immediate need to increase our STP capabilities for the sewers in the country. complete ban and dumping of sewage. You have every alternate day I read in the newspaper that the sewage are being dumped in the Buckingham Canal or the Coombe River. So that comes so there should be strict compliance. So we are not, I think we are lacking that. And whatever required secondary treatment of sewage is essential. Separate sewage and stormwater line for each and every cities. And we need to the sustainable utilization of resources, culture captured, management of waste, plastic, reduction of toxic pollutants. We know domestic waste should be collected. This is another big problem, the plastic. So it has to be recycled and it has to be collected at the domestic level. So once it enters out, whatever the activities we are doing from the land, once it enters to the ocean, we know it is very difficult to collect it or to clean it. So there should be education, capacity building and awareness programs. So the awareness program should be, from our experience, what I understood, everywhere we got a lot of enthusiasm from the people, and what we understand that the education at primary level and adoption of beach, coast or forest, well, our environment by local people, local village, local school, local institution or local university are very important. So that is one of the points we need to address. Similarly, the enforcement of rules and regulations. With this, I thank you, all of you.
Thank you, sir. Thank you very much for your very informative talk. So if anyone have questions, they can ask. We can take 1 or 2 questions.
Dr. Mishra, thank you very much. It was a really good talk. I just had a silly question. You know, Tamil Nadu has, Chennai at least has banned plastic covers and things like that, right, for some time. Have you done any monitoring after that ban? I mean, has it improved the situation?
Well, yeah, that is a nice thing. But the thing is that idea we got, the data, the plastic data, whatever during cleanup we did. So there was till now, though the ban is there, still there are a number of plastics usage are there, or the same plastic bags usage is there. So to have the data, still now we do not have data, but the data how we can collect, maybe another coastal cleanup or something like that we do, then we compare. So that was a plan, because last time what we did for 34 beaches. So there are few states that have banned the plastic bags. So now the next cleanup, whether we'll get some of how much quantity, because we have quantified those the data. I think tomorrow I'm going to give a talk for the MOS on the clean coast. So for the I didn't discuss detail, but if we get some information, because we don't have right now any data, but I cannot say at this point that whether there is a change. But the unfortunate thing that though Elliott Beach, Thiruvanmiyur Beach and Marina Beach are being cleaned every day by the corporation, but the next day will also get the same amount of stress. So that shows that the attitude of the people, because whatever effort we are making, the trash level has not decreased. That is what the data we got. Thank you.
Thank you very much.
Yeah. Sir, one question from me. The share of pollution coming from the land side, we are all talking about taking surveys and other things. So the pollution source coming from away from the coastal waters, that is from the deeper waters, how much is there? Any work happening, something like that? Some data is there, sir?
How much is coming from the other source you are telling? Not from the
Yes,
not from Chennai. Not from Chennai.
Yeah. Not
Okay.
from the coastal area.
Not from the coastal area.
Yeah, some from the marine vehicles and
No,
ships and
because our study, what we are doing basically the coastal area. Okay. So I'll explain like this. because we are doing for the coastal area. So our study is only within the actually our data up to 10 kilometers, and we are regularly monitoring up to 2 kilometers. But our COMAPS program, the seawater quality program, up to 10 kilometers. So within if you see, the entire of the coastal current is the very important point that takes that dissipate that transports the entire the sewage or whatever. So what we have observed that most of the pollutants remain within the breakers zone, and it moves along the in the lateral current. Okay, so beyond that, we do not have any data beyond how much we have not estimated how much pollution is coming from other sources. Like suppose there are some examples I'll show you, like some ships, suppose they are releasing, that ultimately comes to the coast. So we can know what is the origin of that. Okay, those things we got sometimes we encountered and we have seen, but we do not have any regular basis data beyond 2 kilometers to say that how the current system, the bigger currency pattern that brings. So that is what is still lacking.
Okay, sir. Thanks a lot for your very informative talk, and thanks all the participants who have listened to this webinar. Our series of webinars started up and lined up for other days also till 15th. So please do join us. Thanks. I thank once again Purnima Madam and other people who have organized this webinar. I once again thank the two speakers, Dr. Vijaya Ravichandran and Dr. Parvakar Mishra, for giving an excellent talk. Thank you, sir. Thank you, madam. Thanks, everyone. Thanks a lot.
Is it closed, Satya, or anyone else is?
Yes, it's closed, ma'am. Yes.
Yeah. Thank you all so much.
Thank you.
Dr. Mishra, it was really good.